Okay, so in this video, I'm going to show you how to do a question on the binomial expansion. So this one says, find the first three terms in ascending powers of x of the binomial expansion of 3 plus bx all to the power of 5, where b is a non-zero constant, give each term in its simplest form. Okay, so what we need to do here then is we need to expand the function into the different terms for the binomial expansion. So we're going to use the binomial expansion formula. So we're going to start off with the first one, 3 to the power of 5, and then we're going to reduce that each time. So then 3 to the power of 4, 3 to the power of 3, 3 to the power of 2, 3 to the power of 1, 3 to the power of 0. And then each time we're going to start with the bx. So first of all, bx to the power of 0, which would just be 1, then bx squared, bx cubed, bx to the 4, bx to the 5. Okay, and in front of each of those, we're also going to need to have a coefficient, which we can find in various methods. And what I'm going to do this time is I'm going to use Pascal's triangle. So I explained how to use this in a previous video, so I'm just going to write it down. If you don't understand what I'm talking about, then go back and look at the other video. So Pascal's triangle is formed like this. So it's 1, 2, 1, then 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. So the line we need is going to be this one, because it includes the 5, and we're doing 3 plus bx all to the power of 5. So that is going to help me with my coefficients, my 5 choose 1, my 5 choose 2. So I'm going to go ahead and start writing out the terms. So 3 plus bx all to the power of 5 is going to approximately equal, and then the first term is going to be 3 to the power of 5. Then the second term is going to be 5 choose 1. And then 3 to the power of 4, reducing the power on the 3 each time. And now we're going to have a bx term. It's going to be bx all to the power of 1, so I'm just going to write bx. The next term is going to be 5 choose 2. And then it's going to be 3 to the power of 3, reducing the power on the 3 each time, so from 5 to 4 to 3. And then increasing the power on the bx, so bx to the power of 0, then bx to the power of 1, then this time bx all squared. It's only asked us for the first 3 terms, so that should be sufficient. So all I need to do now is to multiply that out and simplify it. So that's therefore going to equal 3 to the power of 5 is 243. 5 choose 1 is 5 from my Pascal's triangle. It'll be 5 times, and then 3 to the power of 4 is 81. Bx, not kx, bx. Then 5 choose 2 is going to be 10. Times, and then 3 cubed is 27, and then bx all squared I'm going to write as b squared x squared. Okay, so that's good. So let's just simplify that a bit more. So it's going to be 243 plus, and then 5 times 81 is going to be 405 bx, and then 10 times 27 is going to be 270 b squared x squared. All right, so that should be my solution. So I'm just going to underline that. That's my solution to part A. So if we go back up, so just check we've got here. So it said find the first 3 terms in ascending powers of x of the binomial expansion of that, where b is a non-zero constant, giving each term its simplest form. Okay, perfect, we did that. So then it says, given that in this expansion the coefficient of x squared is twice the coefficient of x, find the value of b. Okay, so if we go back and we just expand the paper a little bit. So it said, so for part B, it said the coefficient of x is twice the coefficient of x squared. Or it said the coefficient of x squared is twice the coefficient of x. So the coefficient of x squared is going to be 270b squared, and that has to be twice the coefficient of x. Coefficient of x is going to be 405b. So that's going to equal 2 lots of 405b. So my coefficient of x squared is this number here. And my coefficient of x is this number here. And it said the coefficient of x squared has to be twice the coefficient of x. So that's how I've got here. 270b squared is 2 times 405b. Now, what I can do now is I can go ahead and I can cancel out a b from each side, because ordinarily I'd need to include the fact that b equals 0 as a possible solution. But it did say in the question back up here, b is a non-zero constant. So I'm okay with cancelling out b from either side, so I can write 270 b is equal to 810. Then I can divide both sides by 270, so I'm going to get b is 810 over 270. You should be able to see then that gives me that b is 3. So that's a nice, simple, straightforward number, which would suggest I probably got it right. So we finished there. We've got a fairly straightforward question. We've got 6 marks and we've got them all quite well. So we'll stop there. Okay, so I'm going to do another question here. The previous question was from an A-level paper. This question is from an IB paper, but they're pretty much the same idea. So in this one, it says find the term in x to the power 4 in the expansion of 3x squared minus 2 over x all to the power of 5. And this one, we're just looking for one single term. We've got to be a little bit more careful because we've got 3x squared and then we've got minus 2 over x. So if I was to write it out in the form a plus b to the power of 5 like that, then my a would equal 3x squared and my b would equal minus 2 over x. So when I do my expansion, I'm going to start off with a to the power of 5. So I'm going to start off with 3x squared all to the power of 5. Then I would have 5 choose 1, 3x squared all to the power of 4, and then minus 2 over x. Then I would have 5 choose 2, 3x squared all to the power of 3, and then minus 2 over x squared. Then I would have 5 choose 3, 3x squared squared, and then minus 2 over x cubed plus 5 choose 4, 3x squared only, and then minus 2 over x to the power of 4, and then the last term, 5 choose 5, I'm going to skip it out, 3x squared to the power of 0, I'm going to skip that out, and it's going to be minus 2 over x to the power of 5. Now that's the entire expansion. I only actually need the term in x to the 4. So if I can work out which that one is, I can miss out the other ones. So if I look at this first term here, it's going to give me x squared to the power of 5. So it's going to give me power things in x to the power of 10. So I don't want that one. If I look at this one, I'm going to get x squared to the power of 4. So that's going to give me x to the power of 8. And then I'm going to divide by 1x. So it's going to be x to the power of 7. So I don't want that one either. If I look at this one, I'm going to get x squared to the power of 3, which is going to be x to the power of 6, but then I'm going to divide it by x squared, so that should give me x to the power of 4. So that's the term that I want to look at. So I'm just looking for the term in x to the power of 4. So it's going to be 5 choose 2. 5 choose 2 is going to be 10. You can use Pascal's triangle, or you can use the factorial method, or you can use your calculator. You can see previous videos or earlier on in this video to explain why 5 choose 2 is 10. But 5 choose 2 is 10, so it's going to be 10 multiplied by, and then 3x squared all to the power of 3. So I'm going to have 3 cubed, which is going to be 27. Then I'm going to have x squared cubed, which is going to be x to the power of 6. So that's the first two parts. Then the third part, I'm going to have the fraction, so I'm going to square the top and square the bottom. So on the top I'm going to have negative 2 squared, which is going to be 4. So put this in brackets, that will be 4. And then the bottom I've got x squared, so that's just going to be over x squared, like so. So now I can simplify that. So I'm going to have 10 times 200 times 27, which is going to give me 270. And then times that by 4 is going to give me 540, 1080. And then this should give me x to the power of 4. That's why I chose this one in the first place. So I've got x to the power of 6 on the top. I'm going to divide by x squared. So that is going to give me x to the power of 4. So I should now have answered the question. It said find the term in x to the power of 4 in the expansion there. So I've done that. So term in x to the power of 4 here is 1080 x to the 4. That's all I'm going to need for the question. So I've finished. So if you want to find some more questions to practice with, you can go to my website here, which is qualitytutoring.net. You'll see this. If you don't have an account, you can click create an account here and create one. Once you have an account, you'll be able to go to this questions tab here and you'll be able to access the question database. So what I did here is I went to topic and I selected series, which is here. I then went to subtopic and collected binomial expansion. And you can see that there's 40 questions. If I then click on the eye here, I can see the questions here. I can then look at those and try those out myself. If you've paid for it, you'll also be able to view the mark scheme, so you'll be able to see whether you've got the answer right. If you only have the free version, you won't be able to see the mark scheme, but what can I do? Okay, so have a look at that if you want to find some more questions.